Bismillahirrahmanirrahim. New syllabus Physics SSC 1, Unit number 3, Dynamics, Exercise 3, Numerical Problem 3.6 to 3.10. In previous video, we solved the first 5 numerical. Now we solve the last 5 numerical. In question number 6, two masses have 52 kg and 48 kg are attached to the end of string that passing over a frictionless pulley. Find the tension in a string and acceleration in the bodies when both are moving vertically. First of all, write the given data. Mass of first body M1 is equal to 52 kg and mass of second body M2 is equal to 48 kg. Gravitational acceleration small g is always constant. Its value is 10 meter per second square. To find acceleration A and tension T. Formula: when two bodies are moving with vertically, then acceleration A is equal to m1 minus m2 into multiply by g upon m1 plus m2, and tension T is equal to 2 m1 m2 g upon m1 plus m2. In part 1, we can find the acceleration A. Then A is equal to m1 minus m2 into multiply by g upon m1 plus m2. Putting the values, then A is equal to 52 minus 48 multiplied by 10 upon 52 plus 48. Here 52 minus 48, 4 multiplied by 10 is equal to 40. And 52 plus 48 is equal to 100. Then acceleration A is equal to 40 divided by 100. Then 40 divided by 100 is equal to 0.4. So the acceleration A is equal to 0.4 meter per second. Now in part 2, tension T is equal to 2 m1 m2 g upon m1 plus m2. Putting values, then T is equal to 2 multiplied by 52 multiplied by 48 multiplied by G 10 upon 52 plus 48. Then 52 multiplied by 2 multiplied by 48 multiplied by 10 is equal to 49,920 upon 52 plus 48 100. So T is equal to 49,920 divided by 100. Tension T is equal to 499.2 Newton. That is approximately equal to tension T is equal to 500 Newton. So the result, the required acceleration in a body when both masses are moving vertically is 0.4 meter per second square, and tension in the string is 499.2 or approximately equal to 500 Newton. So in numerical number 7, two masses 26 kg and 24 kg are attached to the end of string that passes over a frictionless pulley. 26 is lying on a smooth horizontal surface of the table and 24 kg is moving vertically downward. Find the tension in a string and acceleration in a body. So, first of all, write the given data. Mass of first body M1 is equal to 24 kg and M2 is equal to 26 kg. Then gravitational acceleration small g is equal to 10 meter per second square. To find acceleration A and tension T, we write the formula for acceleration when bodies are, one is smooth surface, mean horizontal surface, and other is vertically downward, then A is equal to M1G upon M1 plus M2, and tension T is equal to M1 multiplied by M2 multiplied by G upon M1 plus M2. In part 1, we can find the acceleration A. A is equal to M1 multiplied by G upon M1 plus M2. So, here putting the values, then A is equal to 24 multiplied by 10 upon 24 multiplied by 24 plus 26. So the answer is 24 multiplied by 10 upon 24 plus 26 is equal to 50. So A is equal to 4.8 meter per second square. Similarly, in part 2, we can find the tension T is equal to M1 M2G upon M1 plus M2. Putting the values, so T is equal to 24 multiplied by 26 multiplied by 10 upon 24 plus 26. So T is equal to 24 multiplied by 26 multiplied by 10 is equal to 6240, and 24 plus 26 is equal to 50. So T is equal to 6240 upon 50. Then tension T is equal to 125 Newton. Result, the acceleration in the bodies is 4.8 meter per second square, and tension in the spring is 125 Newton. Question number 8. How much the time is required to change the 22 Newton second momentum by the force of 20 Newton? So, given write the given data here, change in momentum. Change in momentum denoted by delta P. Delta P is equal to 22 Newton second, and force F is equal to 20 Newton. To find the time T, so we know that the formula by the relationship between force and momentum, then F is equal to change in momentum divided by time. So force is equal to change in momentum divided by time. Now write the solution putting the values in this formula. Force F is equal to 20 and change in momentum 22 upon T. So T is equal to 22 upon 20 is equal to 1.1. So time is equal to 1.1 second. Required result is the time is required to change the momentum is 1.1 second. In numerical number 9, how much is the force of friction between a wooden block of mass 5 kg and the horizontal marble floor? The coefficient of friction between the wood and marble is 0.6. So we write the given data, mass of wooden block M is equal to 5 kg, and coefficient of friction mu s is equal to 0.6. We know that the gravitational acceleration small g is equal to 10 meter per second square. Find force F is equal to question mark. Now write the formula Fs friction is equal to mu s mg. Putting the values, then Fs is equal to 0.6 multiplied by mass 5 multiplied by 10 value of g. So Fs is equal to 30 Newton. Force of friction Fs is equal to 30 Newton. Result, the force of friction between wooden block and marble is 30 Newton. Now, the last numerical, how much the centripetal force is required to need a body of 0.5 kg move in circular radius 50 centimeter with the speed of 3 meter per second. Here we write the given data. Mass m is equal to 0.5 kg. Here given radius in centimeter, r is equal to 50 centimeter. Centimeter convert into meter is divided by 100. So radius r is equal to 0.5 meter. Here speed v is equal to 3 meter per second. Now we find the centripetal force Fc. Then we have Fc is equal to mv square upon r. Centripetal force is equal to mv square upon r. Now find the solution putting the values in this formula. Then Fc is equal to 9 Newton. The result of the centripetal force of body is 9 Newton. In next video with next chapter, best of luck.